All right, so for Lab 7, this is kind of the first lab where we're kind of building on the previous lab. So Apply Oracle Lab 6 should run at the beginning of your Lab 7, and that will just run whatever you have in Lab 6, which sets up a lot of this, because in Lab 7 or in Lab 6 we built a few things. We added some rows and all that kind of stuff. So what we're going to do in Lab 7 is we're going to kind of continue building on that. And I guess the overall goal of this is we want to make it so we have prices for our movies. Because right now we have a way for we can track rentals, what movies people rented, but we don't have pricing built into our database. So Lab 6 and Lab 7 and Lab 8, for the most part. And they actually, a lot of what we do in the future deals with the money side of things, but specifically Lab 6 and Lab 7, we are preparing to create pricings for our movies. And this lab really kind of brings it all together, because in this lab, you'll actually see the last step. We're actually going to come up with all of the prices for our movies. And it's a really, really fun query to write, but it is complicated. So we're going to cover that pretty in depth, because there's a new key. I want to say key phrase. There will be new syntax we're going to use called a case statement that will let us do conditionals where we can make choices and put some logic into our code. So we're kind of going to just jump right in here with Lab 7. And a lot of this stuff is stuff that should not be new. And like I believe I've said this before, that realistically, by the time you hit Lab 5 and 6, most of everything you've seen before. Every once in a while we'll throw just a little something new in, but we go from practicing essentially to actually trying to complete objectives, and often those objectives are just the same steps, just different tables. So for example, step 1, we just need to insert rows into the common lookup table, and I'll try to explain this a little bit as we go, just so you understand the instructions and logic. I probably won't demo this too much, but I do want you to understand why we're doing it, because then I think it'll help make the instructions make a lot of sense, and they should be pretty good. But anyways, we're just inserting 2 rows into common lookup, and all these are going to be our codes for yes and no. And so like you've seen with other common lookup things, we have like Visa, Discover Card, or for like telephone and home, or for address, we have home and work. And this one's going to be even more simple. Basically, we have active flag, and it will translate to a Y and an N as the code, and the type and meaning just being yes and no. One type being all uppercase and meaning being pretty. And the reason we do that is because if we ever wanted to use an actual drop-down menu, you could have it be yes and no all written out, and it all works, because you can pull those values straight from this table. So we're going to insert those into common lookup. And because we changed our design of common lookup in Lab 6, you'll insert into table, column, and code for those, which is really nice. It makes a lot more sense when you insert into common lookup table and common lookup column to know exactly where those point to. And after Lab 6, because that's pretty much what we did in Lab 6, that should be pretty easy. If you need a good example of where you would put that, you could look at your Lab 6 files where you inserted the rows for home and telephone, or for telephone, home, and work, and you could use almost the same query to do that. So that shouldn't be too bad. Like I said, I don't want to go too in depth, because most of these, for the most part, are stuff we've seen before. And this is going to be the same thing, but we're going to insert 6 insert statements, and 3 of those are going to be for price, and 3 of those are going to be for rental item. And so these you'll do your 1, 3, 5, because essentially what we're doing is we're setting it up so customers can rent movies for various days, whether it's 1 day, 3 day, or 5 days, and we charge different prices based on those. And I know these are a little bit antiquated, because nowadays, if you want to rent a movie, you just pop on Amazon, Apple, Google, whatever your flavor of choice is, and you just rent the movie for a day. And if you want to rent it more, you do it. But or you go to Redbox, and it just charges you per day. But if you think back in time to when there was Blockbuster and Video USA and all those good old-fashioned movie rental places, this was what you did. And in fact, just as a I guess to kind of help immerse you in the scenario. I remember when I was a kid, the deal was we would always get to rent movies on Saturdays, because that way we got to keep them for Sunday, because they didn't charge for Sunday. It didn't count as a day because they were closed, so you couldn't return it. So you do a 1-day rental, but you really got it for 2. But anyways, 1 day and 3 day, 1, 3, and 5 day rentals. And so you'll insert those. And because we created the price table, and we are going to put the common lookup stuff to support price type, and then rental item is also going to have the number of day rental on those, because eventually, because that'll tell us how much the price table will say, oh, if I want to rent Hunt for the Red October for 1 day, how much is that? If I want to rent Hunt for the Red October for 3 days and for 5. Because, just like with anything, we have to have our prices set for each one of those days. So Hunt for each movie will actually have multiple records, but we know they're at least going to have 3, and we're actually going to have 6 per movie. And we'll talk a little bit about that. And then obviously rental item type, we have to choose how long they rented the movie for. So there will be just 3 of those to support that. And then on step 3, we are going to add, go ahead. Okay. So on step 3, we add, we're going to update rental item type with values for all pre-existing rows, meaning that because we added the column last lab, but all those values are empty, but we already have a bunch of data in there. So we need to make sure that the rental item price and rental item type, essentially rental item type is the one we're going to update here. We want to make sure that all has the stuff. And so basically we have to calculate, did you rent that movie for 1 day, 3 day, or 5 days for every rental item? And luckily for us, it's not too bad, because we actually have this query here that was given to us, which is really nice, and it will actually take care of this step for us. We actually, in step 3A, we don't even have to do anything. So it says right here that it may have a casting error in Oracle database 10G and earlier. Well, lucky for us, we are on Oracle 11G, and so this will just work right out of the box. So your step 3A is right here. But just to show you what it does, because it's never fun to put something in without knowing what it does. Basically, we're updating rental item, and we're updating the rental item type. We're going to set that to a value. And then we start this subquery. So I always like to kind of start at the bottom of the subquery. So basically what we're doing is we're first selecting the difference between the return date and the checkout date, and that will give us how many days a movie was rented for. Because if we're looking at historical records, so if I checked out a movie on June 1st and I returned it June 2nd, if you subtract the difference between those 2 days, they were only 1 day apart. So that was a 1 day rental. So it selects that. So let's say in that scenario, it was a 1 day rental. This would actually just return 1. And then it delivers that 1 up to this subquery. And so we're selecting the common lookup ID from common lookup, where the common lookup code is equal to 1. And so if we go up to see what we put in here, the code would be 1, right? And so that would narrow it down to either price type, or rental item type of 1. And so then the subquery filters those out right here. And it says where the common lookup table is equal to rental item, and the common lookup column is equal to rental item type. So essentially we're calculating how many days between the return date and the checkout date, 1, 3, and a 5. That should be the results, and it will choose the adequate day rental from the common lookup table, and it will set that key equal to the common lookup ID, and we're all set. And then at the end, you should get this 13 and 13. And it looks like there's an ongoing conversation on Teams about that. So if you're having issues with that, maybe search for that in Teams, because I will be posting some troubleshooting for that here as soon as this meeting's over, actually. It does have this step that will help you track them down, and we'll talk about that in Teams as well. So I don't want to dwell too much on this, but just so you know, it does. This is kind of where the troubleshooting skills are going to start kicking in, because now not only are we dealing just with this lab, but also lab 6. So and grading should be happening faster now. In fact, I will be grading your lab 6s tonight, so that should help a little bit as well with any problems that you might have with lab 7. And so if you have some issues, the big thing to check is, because it should pull up all these. So if you're missing a row, we need to make sure that these are all using full joins. So we just want to make sure that everything's working as far as the where clause. But, maybe go into lab 6 and make sure that your checkout date and return dates for the potters are accurate, and all that kind of stuff. All right, and then on step B, we add the foreign key. And this is where we tie rental item type to rental item. And we had a discussion before, this is rental item 7. If you don't have a 5 and a 6, that's okay. Basically, these are just a number to make the name unique, essentially. And many times, and actually in databases, you might drop constraints. So let's say you build it, you're up to like 10 foreign keys, which would be kind of crazy. You might be up to many foreign key constraints, and you'll drop some. Maybe you change the design of your table or whatever, but you don't go and change those numbers, because that could cause some problems. So most of the time they're just left. So the number doesn't have to be sequential. It's simply a way to make the name unique and to track. So it doesn't necessarily, if you don't have a 5 and a 6, that's okay. They're just simply there to make the name unique, and they're of no consequence as far as the number goes. And so we add that foreign key constraint, because now we have data there. So we add the foreign key constraint. Then the Oracle knows that, these are tied together, and you have the data there that all works. So once all the data is there, we shouldn't have any null values, and we can change the rental item type to be not null. And we've done that before. So you just alter the table and change it to a not null constrained column. And so really these steps 1, 2, and 3 should go pretty quick. If lab 6 is accurate, this actually all goes like a breeze, and it should be very, very quick, which is nice. If you have a problem with lab 6, let me know. We can get it sorted out pretty easy. And like I said, I'm going to be grading those tonight, so those should be you should be getting some feedback on those, because once we start building on each other, I really like to grade the labs Monday and Tuesday. But since we're having our meeting on Wednesday, as you know, yesterday was somewhat of a nightmare for me, so I didn't get to it, but I'll get to it tonight for sure. But the big bulk of this lab is on step 4, and we are going to spend the rest of this meeting talking about step 4, because it is very much logic based. It has a lot of business logic going on, and it's the first time we use cross joins and unions to do some stuff. And it's kind of fun because we actually use them all together, but sometimes it can be a little overwhelming. And so we're going to talk a lot about it. And it should be fun, because case statements are a life changer. And the nice thing is they give you this nice little starting point, which is really nice. So I'm actually going to take this and copy it, because we are definitely going to be using it, because it helps a lot. So I have actually already run my lab 7, I believe. So let's select, let's describe rental item, and we'll know, because rental item type should be not null. So I've actually already ran lab 7 completed, so that way everything's done and ready, so we can actually test this out. And we are going to start writing a little bit of our step 4. And it's actually already got it for us, so we're good. Because you'll notice where it has these ... and stuff, that's where we're going to kind of put it. Now we're going to start building this just a little bit. I don't want to give the whole solution away, but I also definitely want to show you kind of what's happening here. So we're going to do we're going to demo this just a little bit. The first thing I'm going to do is I'm actually going to take and show you what these cross joins do. So as we know, a cross join is multiplication. So kind of what I want to do real quick is I will write my own select statement because we are kind of just going to start building this just a little bit. So let's take this here. I'm just going to put it outside of this spool command so we don't, if we forget to erase it, it's not a big deal. And I'm just actually going to just change this to select everything from here because this is pretty much what we need to run a basic query, and it will select everything. But we're going to just give her a run, make sure she works. Great. So now what I'm going to do just to kind of show you what this is doing is I'm going to select, let's get the I.title so we get the name of the movie. And then we want, because when we select here, we have item I, and then we cross join that with this subquery. And what we get this is we basically select a Y and an N. So if I were to come over here, and we can actually run this, let's just take this little subquery here. And I'm going to take and copy this. Oop, we didn't want to cut it. Let's just copy, add a semicolon. And basically what we're doing is we're building just this little tiny table, and all it has is a yes and a no. And that's our active flag, which we'll talk here in a minute. So we have our active flag yes and a no. So, and because this is a cross join right here, basically what we're doing is we're taking every movie and we're timesing it by yes and no. And in fact, let's actually do this real quick. We will just go like this. So if I were to cut that query down to this and just get the active flag here, we will get every movie in our database, and each movie will have yes and no. Oh, let's try again. Let's describe item, make sure we have the right name here. Item title underscore. And there we go. So now we have every movie that we've ever had. And let's clear columns. And let's set line size equal to 250. Oh, not equal. There we go. So now we have every item in our database, and it's multiplied twice. So we have Hunt for the Red October, and it goes through all the movies, and the active flag is a Y, and then we start over. Hunt for the Red October is a no. And essentially, that's because of our cross join, because everything in item is going to duplicate for everything in this list, which just happens to be a Y and a no. And so, what did I do there? So essentially what we're going to do is we want to come up with pricings for our movies. And every movie according to our logic has been new, and it will be old. And we charge different prices for this. So essentially, let's say we only had one price. Let's say we're Redbox and we just charge per day. But let's say for newer movies, we charge more than older movies. Hunt for the Red October, if it's active, this is the current price that we're charging. Now, we all know that Hunt for the Red October came out forever ago. And so the active price as of today in real life would be that it is the old movie prices, right? And so that would be the old movie prices. But let's just pretend. We're going to pretend. Let's say that Cars just came out yesterday. Cars, the active price for Cars would be the expensive one. And so on and so forth. So Hunt for the Red October, its inactive price, or where the active flag is no, that would be a historical record, one that is no longer active. And like, so for Hunt for Their October, we would have quit charging the new movie prices for whenever we ended. Now, in our database, it's just so happens that it's 31 days. 30 days old, and the movie, we charge new movie prices for 30 days, basically a month. And then once it's been new for a month, then it becomes an old movie. And you can kind of see that here just a little bit in the output, because for every price, we have a start date and an end date. And so the start date is when did we start charging those new movie prices, and when did we quit charging those new movie prices? Or when did we start charging old movie prices? So for item ID 1001, what we're going to end up with is different prices, because you'll notice that it actually has 6 records, and it has different prices depending on what the scenario is. So we know by looking at it that this movie is old, because we have basically on the 2nd of March 1990, we were charging $3 per day to rent that movie. Now, if you rented it for 3 days, it was $10, and 5 days it was 15. And I didn't come up with the prices, so I don't know how they came up with that. But anyways, but we quit charging those prices on the 1st of April of 1990. And then on the 2nd of April, it became an old movie, and we only charged $1, $3, and $5 respectively for 1, 3, and 5 day rentals. So essentially we go to charging $1 a day for depending on how many days you rent it. So you can kind of see how that works. And you can even imagine how this would work for a grocery store. Imagine if you have a sale on an item. When you're talking about taxes or simply, you're keeping your books as far as how much money you make, what your expenses are. You have to be able to track what you're charging, especially, as you're ranking it up at the cash register. If something's on sale, you need to have what you're currently charging for that item and so they would have a price table very similar to this, even with the item. The item ID, in our case, it ties to the item is filled with movies, but maybe it's bread, maybe it's milk, so on and so forth. And the business logic is a big part of this. Like I said, the 31 days is kind of in there and all that kind of stuff, and it should be discussed in here. Right. Somewhere in there, and it might not be on this version, it might be on yours. But anyways, it talks about the 30 days, which is what we're going to do. So we'll spend a lot of time discussing the 30 days that it takes to become inactive.
Brother Crook?
Yep.
I think it's actually in Brother McLaughlin's, I don't know how to say it, his website, his blog. The instructions on his blog have much better details, especially in the help section. It has better details for finishing that step 4 in there.
Okay, perfect. Yeah, so I think, because they're used somewhere, and I'd have to go look. Let's see, it's down, where's Labs 7? There's a place where it talks specifically about the logic. And did you say that was under the help section?
Yes, the help section.
Okay. Yeah, and this actually has some great stuff here. Yeah, this is great, actually. Yep. So exactly. I'm glad you brought this up, because this will tell you kind of exactly how it goes. So, and it even looks like it's a little interactive. Perfect. Yeah. So, you can imagine that if we had a movie, for each movie, this is kind of going to be, this is a distribution of prices. But you can kind of see if we have 3 new release movies and 21 old release movies, you can kind of see how it is. So if we deactivate the new prices, we don't have any more new release movies, but we do have some more inactive prices. So you can kind of read through this, and it kind of just talks about what I said. Oh, and here's the 3 rows in the price table when they're within 30 days of the release date. And 31 days or more from the release date, and it kind of takes you through on how to calculate that, which we'll do here in just a minute. So yeah, thank you for bringing that up. I knew that was there somewhere. I just couldn't remember where. So thank you very much for that, because that is very helpful. So let me real quick, I'm going to erase this because we want to bring all this back. And we are going to, and kind of just to show that just a little bit more, I'm just going to real quick select these few things here. Because really what we're doing is we're using the cross join to fabricate data is what I call it. Because we don't actually have this data anywhere really particularly helpful to pull from. And actually what we're doing is we have our price table. We're actually querying all of the data we'll need for price. And we'll actually kind of just fill our price table from thin air. That's why I like to call it fabricate, because we're going to pull it from various places and then build it. So I'm going to real quick run this one for you. So now what we have, because before we just had yes and no, so we had 2 records for each movie. But now, because we took one, because we're, Hunt for the Red October exists once an item. And then we had yes and no. So we took 1 times 2, and that's why we ended up with 2 versions of Hunt for the Red October. Well, now we took 1 times 2 times 3. So Hunt for the Red October times that by 2 is 2. And then we take 2 and we times it by 3, and that's 6. So now Hunt for the Red October actually has 6 records, because it will be there for yes 1. And actually, let's go like this. We will order this. Order by 1, 2, and 3. That way we can look at this a little bit better, because Hunt for the Red October will have 6 records. Get up to it. Hunt for the Red October. Where are you? Oh, I think it's the Hunt for the Red October. The Hunt for Red October. Okay. So 6 records, because we multiplied by each set. So we have Hunt for the Red October. We have 3 no records, because there's no for 1, 3, and 5. But then there's yes for 1, 3, and 5. So you always can calculate how many records you're going to end up with by going the number of rows multiplied by each table, because a cross table is a Cartesian product, or just simply multiplied. So I always like to use that to validate that everything's working right when I'm writing these, because, and I always use 1, because most of the time you have like one table that's kind of your base table, like item is for us. So I say, okay, Hunt for the Red October, times it by yes and no, that's 2. And then times it by 1, 3, and 5, that's 3. So 1 times 2 times 3 is 6. And then I can come in here and make sure that Hunt for the Red October has 6 records. So it's really nice, because we went from just having 1 to having 6. And you can imagine what this would be like if you had to try to hand type all this data or something like that. So really what we're doing is we're going to use SQL to really make our jobs a lot easier. Now, the fun really starts when we try to come up with prices and start date and end dates. We'll start with the start date and end date, because I think it makes a lot of sense. So, and we're going to kind of use Hunt for the Red October is kind of our big one. So real quick, what I'm going to do is I'm going to add i.release date to this query, and we're going to run it, because I got to find what movie's our new one. I believe Tron is, because there should be one movie. Yep. So Tron, those 3 items you inserted into in Lab 6. Somewhere in there you should have a new movie. And in this case, mine is Tron, and it will always be on the current day whenever it was last. And actually, that's not Tron. Let's look. Let's order by 4. Descending, that way we know which movie's first. I should have did it ascending, because then it would have been at the bottom without having to scroll. In fact, let's just take that off. It'll be easier, quicker and easy. All right. And well, I guess that is the right day. But why is it not pulling for? Is my date might be wrong in my virtual machine. No, that's right. Let's try running this real quick. Let's do.
Maybe you did like -3, -5.
Oh yeah, actually, you were absolutely right. I always put minus. Yeah, I did put a minus. You're right. Because I forget that I'm not. I wrote those before they changed the instructions to explicitly state that. So you're right. I'm glad you said that, so I didn't have to waste all time. So, anyways, but this is Tron is my new movie, and so we're going to charge higher prices for that movie. So we're going to keep that in mind here and watch. We'll watch Hunt for the Red October and Tron as we do this. And in fact, we could even filter that down if we wanted to, which we might eventually. But I'm going to put the I release date in there just so we can kind of see it as we start to do this, because that's kind of what a lot of this hinges on. Because all of our logic, whether when we start pricing and what our actual prices, hinge on whether that movie is old or new. And so what we're going to be doing is we're going to be dependent on that release date, and we're going to perform a lot of logic against that release date column, because that's kind of the keys to our business logic here. So we kind of have this up here. So I'm going to just take and copy this into my query down below, since we already have some of it going. I'm going to take this this thing, and this is our start date. And we're going to implement this logic here. So we know, basically we know that our start date is kind of dependent on it. And we know for old movies or new movies, basically the start date of a price of a movie when it's new is always the day it's released. So what we're going to say is we are going to take our case statement here. So the way case statements works, they're like if then statements. And if you've done any programming, you've seen an if statement. And basically we're going to check some logic. So we say case to kind of say, hey, we're going to make a decision here. And then we can say when. So, and this is on that website, the help section that was very helpfully pointed out. We're going to use this right here, and we're going to say when the release date is less than or equal to 30 days old. So I'm going to get rid of this. So we're going to say trunk sys date. You know, let's just take and copy that. Plug that in there. So basically what we have here is, I think we need an extra, we pull an extra, yeah, there we go. Okay. So when the current date minus the release date is less than or equal to 30 days old. So is the movie new within the last 30 days? And we know that if that's the case, then we can use I.release date as the release, or as the day we started charging those new movies, because we just assume that we have the movie when it releases. And I put that in the wrong place. Let's try again. That's the else. So when it meets those conditions, then I.release date. So if this condition is true, then it returns this value, the release date of the movie, as start date. So that's kind of our column. However, we need to do just a little bit more work here, because there's kind of two scenarios to this. Because let's look at our movies here for a minute. We have Taken here, or Tron. Let's use Tron to be consistent. So we have Tron here, and Tron was released on the 19th of May of this year. So it is definitely within the 30-day limit. So it would be new. But as you remember, we have both the new and old prices for movies. So because we want that historical record. So if we go look at the Hunt for the Red October, which is quite a bit older, you know, we have its records for when it was new, because they're just deactivated, because we want to be able to track all of that. So Hunt for the Red October was released in 1990. But we have its old movie prices and its new movie prices in our database. So we also need to mark the start date of, when did we charge new movie prices for Hunt for the Red October? And so what we're going to do is we're going to add an and clause to, because we want to say, oh, is it a new movie? Because then we use release date. Or, so there's the big key word, or is it an old movie? So let's go back to our help section here because we want to see if it's greater than 30 days. So it's an old movie. And because if we just left it like this, everything would get I.release date as its start date because we have new movies and old movies. There's no in between. So we need to add something else because we want the old movies, but only the records that are no longer active. So we say or af.activeFlag is equal to no. And we can kind of tidy this up because we want to use this all in the same piece of logic here. And just like math, logic works the same as math. If you want one statement to solve itself first or together, you just put it in parentheses. So in this case, this whole statement, one or the other has to evaluate. And actually, instead of or, we want this to be and. Because I got confused. So either it's a new movie or it's an old movie and the active flag is no. So like with the case for Hunt for the Red October, half of its records will be new prices, which is exactly what we want if we look back on our select statement that we had going on there. And so that will get them all as far as the ones that are set to the release date. So whether it's a new movie today or was a new movie at one point, the day we started charging prices for a new movie was the day the movie was released. But that only fills half of our slots. So what's left is old movies. And when did we start charging for old movies? Well, we started charging for old movies 31 days after they were released. So we put I.release date, but then we just add 31 days. So nice and simple, not too hard on start date. Does anyone have any questions about that? Anything fuzzy there? And we'll definitely keep going, but I just want to make sure the case statement makes sense. And that one's kind of big. I think the case statement will make more sense when we start talking pricing because it just look a little simpler. Because in this case, we only had one condition otherwise. So you're either a new movie or it was your prices when you were a new movie, then it's the day you released, or you're an old movie and we started charging old movie prices for you 31 days after you came out. All right, let me check the chat real quick just to make sure I'm not missing anything. Okay, so it sounds like everyone's good there. So let's keep plugging away here. So the next thing we have is our end date, and that's going to be very similar. The only difference is once a movie's old, we don't ever really start not charging for those. And I'm actually going to format this real quick because it really bothers me just a little bit. The way I like to do those is I like to indent the in between the case, and we mark the case as being done, and we say end, and then we say as to name it like we would any other column. But the end tells the compiler, hey, I'm done making decisions for this particular case, step here. But then we're going to do this again for our end date. So we're going to say case, and we're going to say when. And we're going to do some similar logic. It's just going to be a little different because we can actually take a step out of this because in this case, what we want to do is we just want to find the movies that are new. We want to find the movies that are old, but the ones that we charged new movie prices for. So in this case, we want to find Hunt for the Red October when it was new. So if we're going to do that, we can actually borrow the same logic we had up here because we want to find the old movies when they were new. So we're going to take this whole bit of logic right here, and we're going to plug it right here because now we have old movies. But active flag is no, so this is when they were no longer charging those, so that means when they were new. And when they're that, then we set the end date to be i.release date. And since we started charging new movie price, old movie prices 31 days later, it ended the day before, so it's just the i.release date plus 30. And that's when we stopped charging new movie prices for the movie. And we don't worry about the new movies right now because actually this this script will update all the time. We end up doing that later. So really we're only working about filling in prices for our pre-existing data. So for example, Tron will just be new movie price for the foreseeable future. So on that one, we can just say end as end date. And that's our start date and end date. And in fact, let's real quick run this, and we are going to order it by the movie 2, 3, 4. We can take 4 out of it. Let's run it like this. And I think this will really come together once we get the prices in there. Oh, I'm missing something. Oh, I have item in here because we copied off the website. So we just got to change that to an I to match our stuff there. There we go. So now we have all of our movies and that. And just to make it simpler, I'm actually going to filter this down. So I'm going to say and i.item title in the October and Tron. Just so we don't have to look through all of them and scroll as much. We'll just filter those down for demonstration purposes. So now if we look at this, we have Hunt for the Red October. And we have, let me make this bigger so hopefully we can get it all on the same one here. There we go. So we have Hunt for the Red October. Its active flag is no. So let's take a look at these and then our 1, 3, and 5. And we see that it was released on the 2nd of March, 1990. And that's when we started charging for these prices, and they ended a month later. Well, just shy of a month later, depending on the day. It ended 30 days later on the 1st of April, 1990. And then we started charging for these ones on the 2nd of April, 1990, but there is no end date, and that's because we're still charging the same price to this day. So no end date. So there's our start date and end date. So now all we have to do is tie prices to these. And the price, this one should be a little bit simpler because all we're going to do now is we're going to kind of use that same logic, but we are going to just determine, depending on how many days you charge, what's it going to be. But what's cool about this step is we get to do an embedded case clause. So because first we need to decide, is it an old or is it a new movie? So let's start with the new movies. So to get a new movie, we can copy our stuff right here. It's really cool that they give you that to you. I'm really glad that was pointed out. So let's start with our new movie here, and let me make sure we have that one's in there, that one is there. We need to take off that, right? Yeah, okay. Yep. So we have our new movie.
You lost your 0.
Oh, yep. Thank you. That would really be new movies, and I wouldn't get any. So we have our new movie. Then what? Well, we have an additional option because we're not charging the same price for all the new movies because we have 1, 3, and 5-day rentals. So then we do an additional case statement, and then we say case when, and then we use our 1, 3, and 5, which come from dr.rental days, which is our fabricated data down there. And so if the rental days is equal to 1, then we charge $3. When dr.rental days is equal to 3, then we charge $10. And then when dr.rental days is equal to 5, then we charge 15. And then we end that case statement. And this is kind of where it's a little weird. So then we end this other one and we say end as price. So we could actually run this at this point. In fact, we're going to run this just so we can see the price. We should get a price for Tron. And it's stuff here. So here's our prices for Tron, 3, 10, 15. And we get them for all this because we're not filtering out that other stuff yet. Eventually you will, though. In fact, let me show you where it is because you'll see where common lookup and not, it has this and not here. In fact, let's go ahead and throw that in our code down here. We're just going to add that and clause that's built in there. And basically what we're going to do is we are going to find it. We're going to filter out when the movie's new. So essentially, we want to filter out these ones for Tron. Or these ones for Tron, because we're only charging 1, so we only want the ones where they're active right now. So basically we can say where active flag is equal to no, and it's a new movie. So where's our new movie stuff? Right here. I got get this whole thing there. And we'll just put that in there like that. And so now that should filter out those Tron movies for us. There we go. That looks better. So now we have our new movies figured out. So now what we have to do is figure out prices for these other ones. And there's 2 ways you can go about doing this. You can write with an else clause. There's 2 ways. So because technically this Hunt for the Red October that's inactive, this is when it was a new movie. So it should also be 3, 10, and 15. So one solution is we could say when it's a new movie and this, then that. But we kind of already took care of these same movies, right? And we did it with this logic right up here. So what I'm actually going to do to make this a little bit easier is I'm going to just take and copy that because this is the new movies or when a movie was new. So we're going to use that same logic and we're just going to place it right here. And let's see what that does because that should take care of all of our issues and it saves us a step. And there we go, 3, 10, 15, 3, 10, 15 for when our movies were new. Because this one, and then to make this really easy, all we have to do is add this else clause because we took care of everything. So then we just say else, and then we copy our same little structure here, but we just change the prices, and we know it's $1 a day. So 1, 3, and 5. Because we've taken care of everything else and all that's left is old movies. So then we should be able just to run this and end up with all of our prices. So you'll notice for Hunt for the October, when it was new, when it was back in its glory days, Uncle Rico style, we charged $3, $10, and $15 respectively for 1, 3, and 5-day rentals. But currently, the prices that are active, the prices where the active flag is yes, the prices are $1, $3, and $5 respectively. Basically $1 a day. And so what this allows us to do now that we're actually looking at this, because this is actually set for all of our movies. If we were looking at this, when we go up to the cash register and they scan the barcode, it's going to query our database, and it's going to say, okay, where the active flag is yes, because I only want active prices. What is the price? And so they scan it, and maybe we have it bring up how many days you want to rent it for. They type in 3. It'll ring it up, so it'll say, oh, I need the price for Hunt for Their October, where the prices are active. Okay. And for 3-day rental. So that narrows it down to 1, and then it knows to charge $3. And that's the way that would work. But let's say that you do that for a year, and then at the end of the year, you get audited by the IRS, and they say, well, we need to know how much money you made. And so you could go back through and, use your records, your database to query how much money did we make. So you'd go through all your rentals, and basically you would use your historical dates. Because let's say I rented the movie on, I'm just going to pick a day. Let's say I rented it on my birthday on the 17th of March. Now we're going to pretend that I was born the same year that Hunt for Their October came out. So let's say I was born on the 17th of March, 1990. We would look here, and so we would look at the transaction and say, okay, he rented the movie on the 17th of March, 1990. What price would we have charged on that day? And so what we would do is we would say, oh, find a record where the 17th of March was between the start date and end date, and he rented it for 3 days. So the 17th of March for 3 days would be between March 2nd and April 1st, 1990, and for 3 days. So then we know that when I bought it, even though it was years and years and years ago, we charged $10 for that movie. So that way we can track all of our income, our revenue, using our database historically. Any sales you might have, because let's say we did a sale on any movie with Tom Holland in it, or something like that. You could actually run a sale. You would just have to do your start date and end date, and then set your active flag and all that kind of fun stuff. But anyways, that's pretty much what we're doing here. You'll want to use their Husk here because they have different things. And I put price, but it's actually amount. But that should take care of the bulk of the logic there for you. Does anyone have any questions about this or anything like that? I know it's kind of a lot, but I hope, let me ask this. Did talking it through, do you feel like you understand the logic? Do you feel like you can read this and know what's going on? That's kind of what's important, I guess. Any takers? Okay, perfect. Yeah, hopefully that helped because it is kind of complex. I'll be honest. Basically when I started teaching this course, I said, because it's been I had been graduated for, it was the summer, but I hadn't taken CIT225 for about a year. And I actually still had my old cold, but I'm like, I want to just get back in the frame of mind of testing the instructions. So I wrote this from scratch. And I remember when I hit this one, because they actually, when I first started teaching, they didn't give you this. And so when I first started, I was like, ooh, this is a challenge because this is actually a very complex kind of query. So if you can figure this out, what I really like about it is I kind of treat this one as a challenge. I like to kind of hold hands a little bit through it because it is really challenging. But I feel like if you can understand it and maybe start to maybe think about how you could use this to solve problems, that's when it's really powerful. Super, super, super helpful. And just to give you an example, I actually have one of these written that I use every year in my job. And just to kind of give you an example, so attendance is a big deal, obviously, in like elementary schools and high schools and stuff like that. A lot of funding's based on attendance. So at our high school, they have alternating schedules, similar to if you've ever taken a college course from BYU Idaho on campus. Monday, Wednesdays, and Fridays, you have different classes than Tuesdays and Thursdays. And because the frequencies are different, the Tuesdays and Thursday classes have a longer schedule, a longer block. And so essentially what you end up with is two schedules. And our high school does the same thing, very similar. They have a schedule and a B schedule, or they call it a red and gold day. But at the beginning of the school year, or I actually set it up this time of the year, I have the calendar and I have to determine, okay, on Monday, August 26th or whatever day it lands on, is it a red day or a gold day? Because that way teachers know what classes they have, the system pulls it for attendance and all that kind of stuff. And so what I actually do is I actually do a cross join to fabricate the data, just like we did here, to pull all that information. Because essentially what I do is I take every possible combination. So, August 26th would have both a record for a red day and a gold day. And then I just slice it in. I basically take every other row so I can filter through it. Anyways, it's a really nice little query that saves me a lot of manual work, which is always a good thing. So, lots of really fun stuff in here. And this last step is just a really clever way to fabricate some data. And at the end of the day, when we put this all in to our query here, we actually end up with the price table. So if we were to look at price, the only thing we have to add is the who audit columns. Let's actually take a look. If we describe price, we end up with item ID, price type, active flag, start date, end date, and amount. So you can see that just in my query that we did here, we had active flag, start date, end date, and amount, and the item title instead of item ID. But basically what we're doing is we're preparing, because Lab 8, what we're going to do in Lab 8 is we're going to actually insert this data into price. And then we have our price table. So really what we're doing in this last part of Lab 7 is saving a lot of work in Lab 8. Because Lab 8 actually should be pretty minimal as far as work goes, because a lot of it's done here in Lab 7. So does anyone have any questions about the lab, about case statements? Do case statements make sense to everybody?
I have one.
Okay.
Sorry,
Go ahead.
you go ahead first. I'll do something.
Mine was on parentheses, and I just realized I had my mute turned off, so I'm sorry if you guys heard me typing. On the case statement, I noticed you have a double open parentheses before the trunk sys date minus I release date, and then a double close. Do we need to do the double close, or is that?
No, that's probably just because I copied and pasted it and wasn't paying attention. So like that would work.
Okay. I kept getting errors, and I was trying to figure out why I was getting errors.
Yeah, it might have just been, parentheses are one of those things. Thank goodness that text editors added the little thing that highlight the ones for you. I would be lost without that feature. So, because parentheses are just those like tricky little eye things for me that I just can't keep track of them. So.
Okay, thank you.
Yep. And it's actually okay to have the double ones. It will work. But yeah, not needed. Because you'll notice like here we have 2 on this side, but that's because we end this one, but we encapsulate the 2 statements. So like I said, it kind of works like math, where we want this to evaluate as a single statement. You have to be an old movie and have active flag no to have this meet true. Versus this one only has the 1. So you're either a new movie or both of these, essentially is what we're saying. You're either this or both of these, which is really nice because it works just like math. So order of operations should make sense for the most part. All right. And who had the other question?
I was wondering about cross joins, and I'll probably just need to look it up and read about it, but I'm still a little fuzzy on exactly what they're doing. Which 2 you created an AF table and cross-joined it to the item table?
Yep. So, yeah, we can go over that real quick. Basically, because in this case, we want to have two options for every movie, yes and no. And so a cross join multiplies. So essentially we take every movie and we have a fake table that has yes and no in it. And when I say fake, it only exists during the query. So we have active flag column and it's yes and no. So essentially what we're doing is we multiply them. So every item is going to end up with a row that has every possibility of active flag. And I guess just to real quick demo this, let's just make two quick, let's just make a real quick thing here. So let's say, actually, you know what, there's a really great example on McLaughlin's website. Let's take a look at somewhere. He has joins here somewhere. There's a cross join right here. He has a really good example here where he talks about French. And so, our languages. So he has French and English stuff. And this is actually a really great example. So essentially what he has is he builds two tables, one called English and one called French. And where did this go? Because there should be a better example here. I missing this somewhere. Anyways, this prints it out in a weird array. Oh, I wonder if it's because it's not actually working. Anyways, but he has an English table and a French table, and all it is it has the numbers 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. But then it has the translation. So, for example, you can imagine what the table would look like. Where it has it written out. So English table would have 1, 2, 3, 4, 5, 6, and the French would have un, and they skip 2 for some reason. I'm sure he does that on purpose, but un, deux, trois, quatre, cinq, seis, siete. I'm mixing Spanish in now. I am not a linguist. Anyways, but when we cross join, we end up with every possible combination. So in this case, we end up with un, and so on and so forth. We'll also end up with 1, cinque, or 1, 6, which doesn't make any sense because we multiplied everything. Basically, we get every possible combination. But if we were to take and filter those down to say, where ID equals 1 and French, where the English ID equals 1 equals the French ID, where 1 equals 1, then we would actually end up with an actual translation, where 1 is equal to un, 2 is equal, or 3 is equal to trois. We would end up with that. And actually, I'm kind of glad you asked that because, we've talked a little bit about joins. And the old way of doing joins, so, we use inner joins, something like this. So if I wanted to get every contact's telephone number, I could get C dot first name and T dot telephone number. So normally if I want to get the, people's telephone numbers, I would select, contact C, and then I would inner join that with telephone T on C dot contact ID equals T dot contact ID, and then I would get their telephone numbers and their name like that. And we use inner joins, and we know that the inner join is already filtering the results based on a clause. So back to our French and English one, we could solve that same problem without the cross join by doing the join based on the number, right? Because 1 and 1, the actual number itself, not the translation, is the same. So we could do that. But just to simulate this just a little bit, what I'm going to do is I'm going to achieve the same result. So if I select C dot first name and t.telephone from contact C, cross join telephone T. We don't need an on clause because it won't take an on clause because we're multiplying everything. So if I put this in there, I need number, telephone number. When we run this, we're going to get every possible combination, which means that everybody, so we went from having a few rows, like 12, 15. We went from having 15 rows to 225. And that's because if we were to take and order this, order by one, you'll see that everybody has a record for each person's phone number. So, Randy has, Harry Potter's phone number, or Ginny's phone number. I don't know exactly who it belongs to, but we have every possible combination, and we can actually, let's add a little, let's take a look here just for demo purposes. I'm going to add the contact ID from contact and the contact ID from telephone, because what we'll see is we will see the mismatch there, and we'll actually see who that telephone belongs to. So we can see here that, let's go back to Randy. Randy, here's he's contact ID 1001, and so this is actually Randy's phone number, right? Because this is the telephone contact ID, and this is the contact ID. And essentially, before they came out with this inner join, this is how joins kind of worked. You didn't actually say cross join, but when you just perform a join without the on clause, it actually multiplies everything, and then you have to simplify it down. In fact, let's take a look here. Let's look at our inner join, because he actually has this. If we look at the ANSI 89 syntax before they came up with this, they just had a comma separating them. You'd say ordinal French, comma, English. So let's we're talking about the cross join, but you can see how the cross join did every possible combination. For Randy, he has a record for everybody's phone number. So we get every possible combination, similar as if you were to say, I have two dice. Imagine each dice being a table. What's every possible combination I could come up with? That's what a cross join does for us. And we can get the actual result set by using a where clause, and we could say where c.contact ID is equal to t.contact ID. So let's load this up. And basically, we're going to filter those results down to where we get the same 15 rows that we had with the inner join with the where clause. Because basically, we filtered out all the weird possible combinations. We filtered it down. But in the case of Lab 7, we actually want every possible combination. So we don't actually filter most of those down, because we actually want the yes and the no and all that kind of stuff. But let's say that we wanted to create everybody to have a home and a work telephone number. We could cross join our telephone T or cross join contact instead with a little custom query here. We can select home from dual, and we need to put this in here. And then we union it. So a union just joins the two queries together, essentially like adding to a list. Because we've done joins where we glue horizontally, but a union ties them together like adding onto a list. So basically, I'm just making a list for home and work. And we'll just call it TT. So now I can say TT, let's just add this here, TT.type. We'll take out the contact IDs and stuff like that. So now if I were to take this, we're going to get a cross join of everybody's name. Oh, and I didn't do that right. I don't think we need an as here. Oh, and apparently I'm still there we go. We're going to get everybody's name with the option for home and work. So we had 15 people, and now we have 30 rows because, you know, Brian has a work and a home. And actually we have a couple, I think there's 2 Brians actually, but like Randy, because we have Brian Sweeney and Brian Wynn, I think we have 2 Brians, but Randy has home and work, Simon home and work. So on, like Harry, Lily, and Luna, they all have Harry, Lily, and Ginny all each only have 1 home and work. So if you were trying to say, oh, we want to, you know, put everyone's home and work numbers in here for whatever reason, you know, you could do the cross join. Basically, it's a way to duplicate rows based on another set. So in this case, we want to duplicate contact for home and work. You know, we want a record for each. Just like in Lab 7, we wanted item each to have active yes and no. But then on top of that, we wanted 1, 3, and 5. So it multiplies it twice, actually. Does that help at all? No problem. Yeah, we kind of went down a little rat hole there. But it was good because, like I said, to show you the difference here between the ANSI 92 and what we have now, let's take this. I'm going to change this to, you know, because we use cross join, right? But if I take this and just join these with a comma, we're actually going to get a cross join here. Without a where clause, this is actually a cross join. So we get our 222 rows, 225 rows, which is exactly like the cross join. And essentially, the reason why it's an upgrade is because before 1992, the SQL standard was ANSI 89, and this is all they could do. And so if you wanted to get everyone's telephone number, you had to manually, you would load all the possible combinations and then filter it down like this. And so this is the ANSI 89 version of an inner join, because now we only get the records that have a match as specified in our where clause. Now, why did we change? Well, the reason is because it's not as efficient. Because even though we're filtering this out, the computer had to go through 225 rows. Now, that may not seem like a lot, but we only had 15 people and we only had 15 telephone numbers. 15 times 15 is 225. But you can imagine if you're Facebook and you have millions of users and billions of posts, you know, multiply those two together. I don't like, it makes my brain hurt thinking about it. So what they did to save on resource is they made it so, because in this case, the computer generates every possible combination. If we think back on how a select statement, this is why order of operations, that you need to know what order a select statement executes. It starts with the from clause. And so it generates every possible combination right off the bat. So it is doing all the work from here on out for 225 rows, which means that it's holding all of that data in RAM. So if you're Facebook, you're talking about gigs of storage being used, or gigs of RAM being used just to perform these operations. And then it would filter it down, and the filtering down is great, but it had to do all that work for 225 rows. So if you're talking performance as far as time and resources, this isn't very efficient. So what they did is they said, well, let's change this so that we don't have all of that stuff going on off the bat, because when we change it like this on clause is still part of the from clause. So all of this happens in the same step. So essentially we are filtering as we gather the data, which means that it never has to load every possible combination into RAM. And the nice thing is we end up with the same results because the from clause executes all at the same time. So it filters as it reads through the tables, and we end up with 15 rows of data. So really it's about resources and performance. Anyways, that's kind of a deep rabbit hole, but I hope it kind of helps that those joins make a little bit of sense, and all that kind of fun stuff. So anyways, if no one else has any other questions, we will call that a wrap on this one. Does anyone else have any other questions about this lab? Yes, I will share that with you on Teams. For sure. Alrighty. Thank you all for coming. Again, I apologize that we're a day late. Yeah. I know that a lot of you like to get started early, so I feel really bad about it, but I was stuck. But I do feel bad. Just know that I feel really bad. And hopefully this helps. If you want more, I have been posting the previous semester recordings. Earlier, I posted with the announcement on Monday, just in case you want to get started earlier. And I don't know, maybe they cover something that I missed somewhere else. Who knows? So anyway, thank you all for coming. You guys had some great questions, and everyone's going to benefit from them. So, applause for everybody. Thank you for being here, and good luck this week.